Mm-hmm. Okay.
Okay, so we're going to start with our first panelist, who is Sarah HelfinSiegel, and we'll let you take over, Sarah.
All right, hi guys. Hi everyone, I'm Sarah. Just to give you guys a little bit of background about me, I graduated from the University of Maryland from a PhD program in neuroscience and cognitive sciences in 2011. After that, I spent a little bit of time still on an academic track. So I got a postdoc. I actually spent a very brief time as a research faculty member here at Maryland. And then I decided that wasn't really the right fit for me. I wanted to move into data science. And so I ended up finding my first data science job just by, so I had done a lot of machine learning in my academic work. So I had some background in that. I sort of, while I was in the process of applying, took a couple of Coursera courses on it just to sort of bone up on all that stuff. So it was fresh in my mind when I was making my applications. I wanted to stay in the DC area. So I sort of found jobs that seemed like they could be good fits. We're sort of looking for candidates who didn't necessarily already have experience as data scientists, but came from a PhD background, understood experimental design, statistical reasoning, had machine learning experience, stuff like that. Applied to a few of those jobs, and I got a job working as a data scientist for a company called Wedding Wire, spent some time there, and am now doing similar work working as a data scientist for an app called GetUpside. So that's sort of my story in terms of the kinds of things I do every day. It really differs a lot from day to day, but a ton of it is sort of one, helping people like understand, take a business question and understand like how to use data to answer that question, actually answering those questions, and then also doing a lot of sort of traditional machine learning work. So, like building a model to predict the likelihood that a user is going to stop using our app, something like that. And I would say in terms of skills that I really use a lot, one is thinking about experimental design. One is statistics, for sure, a lot of statistics, machine learning, and then the other one would be computer science skills, because often you have to implement this stuff using Python or R typically. In terms of the role that networking has played in my career, I know that's something they wanted us to talk about a little bit. My first job, I found sort of the old-fashioned non-networking way, but I did definitely, before I started that process, I talked to a friend or two of mine from academia who had gone that same route and asked them about, how they found their job, what they were doing in their job, just sort of getting information about how to frame my skill set in a way that would be appealing to these kinds of jobs. And my current job, I actually found because a friend of a friend worked there, knew I was a data scientist, and sort of reached out to me about possibly coming to work with them. So not sort of formal networking, just happening to know someone through my sort of social network. And then in terms of advice that I could give you guys, for me personally, like it definitely would have helped to spend more time really building the basics of computer science skills. Obviously, I don't know if all of you guys, what kinds of backgrounds you are, what programs you're in, but for me, I learned computer science as I went. I learned how to program in R and Python just because I needed it for what I was doing in grad school, but I never learned sort of any of the fundamentals. And I still to this day feel like it would make me a better data scientist to just understand more of those fundamentals, because I don't always code things in the most efficient way, the most replicable way, stuff like that. And I mean, for certain kinds of data science jobs, it would be a real hindrance. The kind of work I do, it's less important to always be doing things in sort of the cleanest, most computer sciencey way. But it really depends on the kind of role you're in. It still would be very helpful to me. So if you're that kind, if you have that kind of background, I'd say, take a basic computer science course or, something on Coursera to kind of just get those fundamentals in place. And that I think is pretty much it for me.
Thank you, Sarah. Okay, so we are gonna move on to our next panelist, who will be Ann Jorstad. So Ann, take it away.
Hi, I'm Ann. I did a PhD in applied mathematics. I graduated in 2012. And then I went and did a postdoc at EPFL in Lausanne, Switzerland. This was not because I wanted to stay in academia. I definitely did not want to stay in academia. But it turns out you can use the postdoc route to just move to another country. And this is an amazing thing that we have the opportunity to do as PhD graduates, is you can apply to a postdoc almost anywhere in the world. If you speak English, you have a pretty good chance. And if you are coming from a university in the US, you are somebody that they want. So if you want international experience, this is something you can just do. You can apply for a postdoc abroad, spend 2 years abroad. Now, it turns out Switzerland is really nice. And so I was planning to come back to the US after my 2-year postdoc, but it turns out it's nice here. And so I got a job here and I stayed, which it turns out is also possible. It's much harder. It took a lot of luck that I got a job because as a non-European, I'm sort of a third class, I'm not even a citizen. So they have to hire Swiss people first, European second, everybody else third. But it turns out luck can happen and I got a job. So what do? I am a data scientist at the Swiss National Science Foundation. So that's the Swiss version of the National Science Foundation. Because Switzerland is small, all grant subjects come from the same organization. So it's basically like the NIH and the NSF put together, which is really interesting because it means that we cover all different disciplines. And because Switzerland has a lot of money, there's actually a lot of money put into research. And so it's a really interesting place to work because we have a lot of data. And what do I do as a data scientist? Well, I perform data analyses to support evidence-based policy decision-making. In this case, it's science policy, because the people who fund science, they get to guide how science works. So as a PhD student, I never really paid any attention to where funding happened. My advisor had money and I just did my research. Turns out it's actually quite interesting from the policy side. I was always interested in politics. I was in the graduate student government at Maryland. So this was sort of a natural thing for me to do, but I always assumed this would be my midlife crisis job, that after I worked for a while in some domain, I would then have my midlife crisis and then go and work for government. But after my postdoc, I randomly came across this job ad. It was really quite random. It wasn't completely a match with my profile, but I had about 2/3 of what they were asking for. So I figured I would apply and see what happened. And I got an interview, and because I was excited, I guess that was enough and they hired me. So lesson number 1 is nobody has all of the things that people are asking for in a job ad, like literally nobody. So if you have more than half, feel confident that you are legitimate to at least apply and sell yourself for the part of the job that you are interested in. That's really important. What else do I do at my job? My job is really interesting. We do projects like, for example, tracking women grant applicants and comparing their success rates to those of men to see if, because generally we know women tend to receive less funding. We perform statistical analyses to adjust for confounders to see if this is actually legitimate or if it's just because women are coming from disciplines or universities that are underfunded, this kind of thing. I've used machine learning and text mining to match grant applicants to the most relevant reviewers. This is interesting because it works really well in the biomedical fields and it works really terribly in the social sciences and humanities. And it's a really interesting project in terms of interdisciplinarity, because if you can identify some parts of a research project but not others, this is an ongoing research. So in some sense, I continue to do research even though I absolutely left academia. I am not a researcher. Feedback. Sorry about that. Is it okay? You can hear me okay? Can somebody nod? Yeah, okay, sorry. Another type of work that we do is we maintain open data portal, which is all of the grants that we as an organization give for all of Switzerland. We give the public a lot of information about those grants. We give what we can publish about data analyses about those grants. And I think this is really important to promote government transparency. So that's also something that is part of my job. So what are the skill sets that I need for my job? R, Python, basic web development, certainly. I need statistics, and I never took statistics. Despite the fact that I am an applied mathematician, I have 3 degrees in math, I never actually took a course in statistics, and I really regret that. So I've had to learn that on the job because statistics turns out really useful. Also very useful is being able to take non-technical requirements and turning them into technical requirements, because usually the people that want you to do a thing, they don't actually know all of the technical details. So being able to talk to non-technical people and figuring out what they want and then turning that into technical results, that's a really important skill set. Mentoring. Yeah, what I would suggest is ask for advice from anybody you have access to. You don't have to take their advice, but ask for advice. If you talk to 3 different people that you respect and they all say the same thing, that's probably a useful piece of advice. Whereas if they all say something completely different, it means it's clear that there's not the right answer. And I think that in itself is really interesting. Join groups that you're interested in. If there's something, whether it's professional in your office or outside of your office, do something that you are actually interested in, because then you want to be engaged and it lets you meet a new set of people and a new set of ideas. And last, I would say, listen to what other people say. So when you're actually talking to them in whether it's a networking event or not a networking event, actually listen to them and see what their problems are, because if you can engage with their problems, they are much more interested in engaging with helping you in the future. So I think that's all the time I have. That's all for now.
Thanks, Anne, and we look forward to hearing more when the Q&A starts. So with that, we're going to go to our third panelist, Janis Constantinides, and take it away. And we can't hear you.
Yeah. So hello, everyone. My name is Janis Constantinides, as it was mentioned. And first of all, let me just thank you for this opportunity to be part of this conversation. I think that it's a great resource that you've put together, and I wish that I had that available to me way back when. I come from prehistory. I got my PhD at the University of Maryland back in 2001. So it was definitely a very different environment at the time. And so I guess the standard disclaimer about past performance not being indicative of future returns and your mileage may vary apply to what I'll say. So I got my PhD in the same program, almost the same program. And I got my PhD in math, not applied math. And we shared a building though. And, you know, it's really like my path and my progression in my studies was I got my bachelor's in math, pure math. Then I did my PhD in as applied a field as I could without actually being in the applied math program. I worked in harmonic analysis. And then I did a postdoc in computer science at the University of Houston. So the way that I saw that as a natural progression and a thread was that, you know, and I didn't know it at the time, but because data science was not a word, but we were interested in, you know, my research, we had been interested in data, right? And applications, and in learning how do we best answer questions. So I was always motivated by not just like what's a, you know, what's the proof to a theorem, but how do you aid decision making? And I think that what I would say is that for me, the key point of data science is that it is a tool for decision making. And you have to understand who needs to make a decision, what decision they need to make, and you need to help them. You use statistics, you use math, you use computer science. But really, where it starts is in understanding that some action has to be taken. There has to be impact. It's not just, so, you know, doing math and proving optimization theorems and all like that, or looking at algorithms was just ways of making sure that the decision-making process could be trusted, right? If you have a theorem that says that's the best algorithm, then you can trust the decisions you make, right? In whatever way. So, like, I would say that, right now, again, I'm a little bit of a hybrid because I do work with a spin-off company from the University of Houston, and I consult with some other data science companies, but I also have a part-time appointment with the University of Houston where we teach some data science courses. We have an honors program and really I did that because I felt that I found a group of people that cared about talking about data science and preparing students in a more holistic way. Again, one thing that I would say, and I don't know if I'm being non-linear in what I'm describing, but I hope it's okay. People tend to focus on like the hard skills, and those are needed. Statistics, computer science, absolutely. You need to know how to code. You need to know some basic statistics. And I definitely could have taken more when I was studying, but that's just not enough. What you need to think about when you're doing data science is you need to think about, and what I think about a lot is data, where to get it, how to get it, how to clean it, how to tie it, how to secure it, how to safeguard it, how to get it ready for pre-processing. I mean, it's a cliche. People say 90% of the time you end up working with the data, 10%, the final 10% is where you run your model. But it's true. And people tend to think that 90% of data science is machine learning. Like, do I use XGBoost? Do I use the latest, convolution net? No, that's not what it's about. Data science, it's about understanding the connection between the data that was mentioned and mentioned, like there's that connection, there's that translation between being non-technical decision maker and a technical analyst, and being able to make that connection so that whatever comes out from one end can be trusted at the other end. Because data science, again, is a collective enterprise. So, let me not say there are no unicorns, but there are very few unicorns that can do it all in data science. So what you need to know is you need to know how to work with other people, how to leverage their skills, how to communicate. One of the things that I did in my career for a while, I was doing research development. I was helping people put together teams and nucleate, new interdisciplinary projects based on problems and go after grants to fund it. And the reason that I did that, and the reason that I liked it, and the reason that I feel it maps to data science is because you have to be very clear about how the pieces fit together. Okay, it's not that someone will give you a spreadsheet that's already, prepared, and you just run your algorithm and it's a Kaggle competition. It's really about understanding what are the key benefits that you would get out of accomplishing, finishing the project. And there's people more qualified than me to talk about what funding agencies want on this call, since they work for one. But I think that you would agree that one of the key things is that the so what is key in a proposal, and it's
1
key
million.
in data science. So what else do we have? So I talked about skills, about communication. Everything in data science is outcome driven. It's not about silos. It's not about what you bring to the table in terms of, what courses you took. It's what do you bring to the table in terms of being able to understand what the need is, if you're in industry or whatever, and being able to act on that. And so I would say that the networking that was the thing that I tried to do in my networking. Okay, so every job that I've had, I got because I networked. Now, it may not have been traditional like LinkedIn. We didn't have LinkedIn 20 years ago, but you have to talk to people and you have to listen to people. And what worked for me is talk to them and ask them about the problems that they care about. Not the problems that they work on, not the problems that they've worked on. Tell them what they care about and listen. And if you can find ways to contribute to the problems that they care about, they will find ways to work with you, right? They will find ways to engage with you. So you're drinking a beer with your mates, when we are back able to do that, talk to them about what they care about. You're on LinkedIn, ask what people think is the important thing that we need a breakthrough on, things like that. So I think I'm out of time, but I'm happy to expand more if I left something out in the question and answer section. Sorry, I get excited talking about these things.
Thanks so much. Thanks for that insight. Okay, and so we're gonna go with our final panelists and then move on to Q&A. So lastly, we have Anand Ramanathan. So take it away, Anand.
Yeah. So hi everyone, I'm Anand Ramanathan. I did my PhD at University of Maryland, graduated in 2011. And I actually also did a postdoc for about, a postdoc, and then it got converted into a semi-permanent position for, so I was at NASA Goddard for 6 years. And then I moved to data science. So I sort of had the experience of being both a PhD student and a postdoc and looking for, opportunities outside. So I think the primary reason why I moved to data science was when I was at NASA, I was doing good work, things were going well, our instrument was doing well. But what I found was, there's no guarantee of funding as you go down the line, and funding was, pretty hard to get. So, I realized that, this thing is not going to last forever, or it's going to be very hard, or I'll be ending up spending my time writing a lot of grants, which I didn't quite enjoy. So I started looking out for data science jobs. So I can echo everything that everyone has said so far. It's all been good advice. I think I agree with all of it. So definitely network, talk to your friends who work in industry, learn to, I think the hard part is, when you work in your, in academia, or even when I was in a research group at NASA, you actually spend a lot of effort communicating to other scientists. I think you should also spend a lot of effort communicating to people who are not in your field or people outside, and make that as a habit, because that sort of really pays you well when it comes to applying for a job. So I took some Coursera courses back then. So, when I was in graduate school, the version of this event, it was kind of funny. We're talking 12 years ago. And, the people that spoke for how to get a job in industry, or an industry panel, were, I think, 3 people, none of whom had PhDs. And, and I think that none of them were UMD graduate students also. So you've really come a long way in sort of sharing this knowledge. So this knowledge is better known. And I think this panel is really great. I think all the advice that Susan gave, all the charts that she showed were really, really good things for all of you guys to sort of internalize. And really think about the opportunities that are there outside. So coming back to where I was, I started looking for jobs. I networked, and I think what I did, which worked out well for me, was I took my time. So I think I started applying started looking out back in 2013. Did some Coursera courses. Then I actually applied initially a little bit in 2014, 2015, and finally in 2016, when applying initially gets you feedback of what worked and what didn't. So I got some good feedback from interviews, and then in 2016, I was continuing to network, and I finally applied at Capital One, where I managed to get a position in. And I think I'd say the skills that you need to get a job in industry are somewhat different from the skills that you need to do well in your job at industry. So the good thing is, once you're in industry, you can actually focus on the latter a lot more, and actually build towards giving value to the people around you, to your, your company or your organization. But getting in is challenging. So I think that is the hardest step, I would say. So for me, that was the hardest step, because I had no idea what was no idea how to get beyond it. And for me also, I would say that the first few months in Capital One were challenging, because I was trying to figure out some of the thing that Ioannis mentioned, like, hey, how do you work with other people? And not that I couldn't, I had worked with other people, but here you have, like, when you work in a research group, you have maybe 3 to 5 people you work with, or maybe if it's larger, like 9 or 10. When you go to a company, your work actually intersects with, like, I think 20, 30 or even more people, and you have to communicate differently to different sets of people. So I think for me, understanding how what the organization structure works, what do you have this what's called your leadership chain. I was like, okay, what do all these people do? They get paid a lot. What do they do? And I think just understanding that was a lot of my learning when I first joined Capital One. Once you're in, there are and you get settled in, it's actually you do get to enjoy the good parts of being in industry. Like, there's a lot more job security than what I had when I was at NASA. And the other thing that I did, the other thing that I do enjoy actually is a lot of, there is scientific rigor and there are interesting problems even in industry. And I think the really important thing always is to make sure, hey, is this valuable for the business? As everyone else has mentioned, how is this helping the business? And always be aware of that. There are lots of interesting problems that probably have no value or little value. Like, you can spend 6 months building a model, but maybe the model has no real value for the company. And I would encourage you all to be aware of them, but don't dive right in just because it's interesting. And I think the one thing in industry that I found is different from my postdoc and my PhD is that I think people they don't, by default, you don't get as much time to sort of, I would say, what we call play. Like, say you wanted to explore or read up, spend a week reading up about something. When I was a grad student, I could just do it. I didn't have to ask anybody. I could just do it. But in your job, you have to be very, very focused and say, okay, I'm going to spend a week doing, or 3 days doing this or something like that. You've got to be very, very focused about your learning. So that's some of the skills you need inside industry. Coming to what advice I would give people who are applying, I think definitely talk to your professors, figure out how grant writing works, understand how what you do helps your professor get more funding. I think just the business value of what you do. And I think in academia, it's not a default where people share, not everyone shares that with you necessarily. And I think it's always good to ask. The other thing that you can do while you're still in your PhD and postdoc is write a proposal. Writing a proposal teaches you a lot about the business side of things, teaches you how to think about, okay, how much effort is going to take, teaches a lot about planning, about budgets, if you get a chance. These things are some things you can do in your current role that will help you. And finally, I think outreach is also good. Talk about your work. I attended Maryland Day and people ask me about my work. So practice talking about your work to people that are not necessarily technical. Just to finish, so I was at Capital One for 2.5 years, and then I moved to my current role at Audible, and where my role involves Audible spends a lot of dollars on marketing, and my role involves designing experiments for measuring what value that's given to the business, and talking to stakeholders and telling them, okay, this is what we spent X dollars here, this is what it gives us. And it's actually a lot of fun because you learn about how these different platforms like Facebook, Google, and other things work. So I am enjoying my job. I do get the scientific satisfaction in doing good work. Okay, I'll stop there.
Thank you, Anand. All right, so that concludes the panelist story part of the session. And we're going to be moving on to Q&A. So I'd like to first thank our panelists again. Thank Anne, Sarah, Ioannis, and Anand. Let's use reactions to thank them. Feel free to pick your reaction. Maybe not the laughing emoji, but so we're gonna move on to Q&A. The way we're gonna do this, I guess, is maybe we can use the raise hand feature, or feel free to type questions into the chat. Amanda will be monitoring the chat for us. And so if you have a question, you can raise your hand. I encourage you to, if you feel comfortable, to turn on your videos. I mean, there's a slight networking component to this event. So it's nice to be able to see each other. And yeah, so I will just kind of monitor the raised hands. I apologize if I don't get to you in the same order that you first raised your hand, but I will go with what I see on the panelist or on the participants list, and we'll go from there. So I see Nick has his hand raised. Go ahead, Nick.
Thank you very much, and thank you very much to the panelists. So I often have graduate students who are interested in data science jobs, and some of them end up taking jobs at the FDA and doing research science work with them. One thing that I'm challenged to do is to give them a sort of specific list of skills that they need to develop. And all of you have given me sort of broad categories of skills: stats, programming, web development. But I'm hoping to dig into those a little bit deeper. And the reason why is my first job after college was, we'll call it data science junior. And anytime I did anything more than a multiple regression, people's eyes rolled into the back of their head and they lost consciousness, and the board got very angry with me. And so I'm wondering, in the modern era, because obviously things have changed, like, what are the most desirable skill sets? Are we talking about like latent growth model, structural equation model, multi-level modeling, or is that stuff not even necessary for most of the graduate students who are going to be doing in this? Similarly, for people who are willing to talk about it, in terms of programming, it seems like programming is, again, a heavy emphasis. Like, what are the core programming skills you need? So people mentioned R and Python. Like I looked at both and decided R was for me in terms of data analysis, but I understand that Python's better for web development. Do graduate students really need both of these, and to what level of proficiency? And yeah, I mean, so I've got many questions, but since that's already a huge compound question, I'm going to stop there.
Anne, you want to?
Sure, yeah. So your first question was what technical skills? I think it's still similar to what you described, that when you use an advanced model to do an advanced thing, people are afraid of the results and they don't understand it. And so in a lot of situations, if you do much more than fit something linear, people don't trust the results. And so that is something to take into account. It's not that there aren't situations to use the more advanced stuff, there are, but a lot of the work, at least I do, really is seeing how far things deviate from linear. And you're describing how if two data sets are similar enough, or if there's actual difference between two data sets. That's a big piece of what I do. And our audience, which is often politicians, if you get more complicated than linear, their eyes roll to the back of their head. So there is a point of keeping it simple so that people can understand. That said, there's a different type of stuff that we sometimes do, that there are people who think you can just solve everything with machine learning and data science, and just fix all of the things that exist, just use your code to fix the things. And then that's also hard to manage expectations, because people truly believe that you can do magic with the data they provide you, which is full of holes and not consistent, and as we all understand with data. So I was, at least for my job, using the most modern advanced technique is usually not the correct solution. Usually using something simpler is better. But being aware of the modern stuff is also good. Your second question was about which coding language. I use mostly R in my life, but I prefer Python. When I started my job, I didn't know R at all. So I took the Coursera course from Johns Hopkins on R in order to be able to say that I knew R on my CV, and that was enough to start. But certainly now we use dplyr and the whole tidyverse a lot, and this is very important. And I wouldn't hire somebody that I didn't think could write tidyverse code cleanly after a week on the job. but I would, knowing that I learned it very quickly because I already knew Python and C and MATLAB. I mean, once you know a couple languages, learning a new one is fine.
Thanks, Anne. Would any of the other panelists want to complement that?
Yeah. So I would agree basically with what Anne said, that it can sometimes, people can distrust really complicated statistical approaches. I've done, some stuff a little more, like a hierarchical linear model, a PCA, things like that. But I think one part of that is if you're in a context, so, I'm in a fairly small business, the sort of decision makers in my business really trust me. And so they often are willing to trust that the way I've done something is a valid or correct approach. And I think the better you are at being able to explain what you did and why, the better able you are to use those tools. But I would say that in general, both with programming and with statistics, it's much more valuable to have a sort of shallow, broad knowledge for data science than a really deep knowledge, because a lot of times the thing that's most important is to know what kind of approach is the right approach to use here. And that's for machine learning as well too. A lot of times just knowing, oh, this is the kind of problem that can be solved with X. And then if you encounter one of those problems, if it's a priority to the business, either you can find someone, if there's another data scientist around who's done that before, they can do it, or you can then dig in deeper to learn how to do it, but it's really that challenge of saying, oh, this problem, we can't use a linear regression here because of, this issue, this is, it's not going to fit linearly, we have to use a different approach here. What could that be? So it's just sort of understanding the basics of a lot of different things is more important than having a really deep understanding of certainly something like latent growth modeling, and the same thing with programming. You don't need to be like a sophisticated programmer. It's really, and particularly the kinds of programming you need to do mostly is data manipulation is the really big one, data manipulation, and then models, so it's like, if you understand dplyr in R, if you understand pandas in Python, that's like, at least for me, 90%, 95% of the work you're going to do. And then additionally, knowing about scikit-learn and what kind of tools are in there for Python and the equivalent for R. And in terms of knowing one versus the other, the value in knowing both is that some companies will work exclusively in R, some companies will work exclusively in Python, and they might be unwilling to hire somebody who doesn't know the other one. So that's the value of knowing both. Many companies will be willing to hire somebody who knows R but not Python, even if they're a Python shop, if they believe that person can learn it, which again, if you know R, you can learn Python. If you know Python, you can learn R for the kind of stuff that data scientists do. Yes, that's a really good point, is that SQL is something that's absolutely essential. Again, it's something that's pretty easy to learn on the job, but if you come in knowing it, that's going to be a big plus.
Can I ask one really quick follow-up question there, which is, I like this notion of shallow and broad approach in terms of preparing graduate students, and I think it problematizes the way in which we train graduate students for academic life, right? Because we're going deep and narrow most of the time, right? Even in our stats classes, it's like, hey, let's derive this using some calculus, never going to be applicable to data science jobs, it sounds like. Almost everyone here mentioned Coursera courses as part of their personal development. Are there specific Coursera courses you would recommend for graduate students to make sure that they've got the broad shallow? Or specific approaches? Because again, I want to be able to point them towards stuff and be like, our classes are going to give you depth of knowledge, but if you want breadth of knowledge, here are some resources.
Oh yeah, that's a good question. I can't remember. They had like they have like a million of them now, I'm sure, but it's like, there was one that was a sort of machine learning oriented course in R that I took when I was first doing this process, but I can't remember exactly which one it was. I'd have to go back and dig. I don't know if anybody else has recommendations on that front.
I don't have a specific one, but I would encourage anything that has to do with data visualization, because that's super important to be able to make nice visualizations. So you might as well learn the new language by making nice visualizations.
And just to add a little bit, because so when it comes to software, Okay, there is definitely a flavor of the month. I mean, if you were doing deep learning last year, you were working with TensorFlow. If you're doing deep learning this year, you're working with PyTorch. So the point is that you cannot be too wedded to any particular framework. Ultimately, one of the things that you'll find is that, I mean, scikit-learn, you mentioned scikit-learn. There's these very advanced high-level libraries that are widely available. And so it doesn't matter if you're doing R or Python, like you're not going to be coding the way that we were doing like PDE simulations in 20 years ago. Like you're doing, 10 lines of code in scikit-learn will give you a full pipeline for processing your data. 10 lines. All the complexity is hidden away because you're working with a prototyping. The way I think of data science is rapid prototyping cycles that are completely, self-feeding loops. Because even if you train a model and you make a decision, I mean, 3 months later, that model is useless. Your population has changed. You have to retrain. Like you're not trying to solve, you're not making inference with data science. You're not trying to find like the factors that affect for, in a platonic ideal way. You're just interested in the here and now, in the data that you have, and the data is going to change, and you're going to have to retrain, and you're going to have to work again, and maybe the software will have changed by then. So you have to be flexible. The thing about the thing that you learn, I think, as a PhD student, right, working on your dissertation, is to do your own, to be an independent learner. And that is a key thing. Like you have to be able to, do a quick literature search for your project and be like, okay, I have this type of data. What's going on? Like, what do people use for this? And then, how can I find a couple of quick introductions to get an idea of what's happening? It's not about, okay, well, I know I have this hammer and everything else is a nail, right? So it's that what was mentioned, like you need to be broad, not very deep necessarily. So I would say, you need to know basics about coding, but if you know how to do a basic program like a 101 in Python or R, you'll be able to pick up what you need for the other. Now, there is a caveat, okay? These are generalizations. There are situations where things are very different, okay? If you're trying to get a job working for Google X or like the Facebook artificial intelligence research groups, right? I mean, then yeah, it's like very, very specialized, but those are pretty much academic research labs run by companies. This is a completely different scenario. And what's needed there, right? Yeah, I mean, it's not just enough to have a PhD in computer science. Like you have to have a PhD in computer science that has like computer vision background. And then there's only 3 jobs that you could fit in that company. But for the general type of data science public, what's more important is being able to show that what you do produces results that can be trusted, going back to what was mentioned, and not so much. So people need to see that you have outcomes, okay? The students, I would say, they need to think hard about how they can present the outcomes of their research, not the methodology. And that's not something that we think about. When you write a paper, like, yes, NSF asks for a broader impact section, but, it's really about the methodology when you write it. And the way, in my experience has been, is people will be willing to say, okay, you're the expert in the methodology. They're not willing to say you're the expert in what conclusions, right, make sense for the company. So they have to understand that you are listening to them on the what matters for the company, and they will cut you slack on whether you're doing linear regression or whether you're doing decision trees or something else. Again, that's my experience. Take it with a grain of salt, listen to others, see what the consensus is.
All right, thanks, Janis. And I see, Anand, you put some comments into the chat, so I'm going to move on to the next question. Hopefully, if you wanted to convey anything, that's pretty much it. But I do want to give Will a chance to voice his question.
Thank you. Yeah. So something Sarah said that spoke deeply to me is not being an expert in computer science and certain fundamentals of programming. And something I'm curious about in the context of looking at data science jobs is how to identify jobs that are looking for more of a scientist who's skilled in understanding data and experimental design versus someone who is an expert software developer and can make things very fast and efficient and clean, and that kind of thing.
I could take that. Good question. So well, I think the first thing is actually to look at the job ad, and it should say the skill. If it's a well-written job ad, not just boilerplate, it should say what they're looking for. And there's a lot that comes into data science, so there's no special categories. So look at the job. The job ad should tell you a lot about what they're looking for. And I think also to the more general question is you really cannot. I think Sarah's advice of being broad and shallow is very valuable, because you really cannot predict how the jobs are going to be. The trends are going to change, things are going to change, and I think the best you can do is keep your knowledge broad and be able to learn something and dig deep when you need to.
I would add that in the job ad, if there's a part of it that has to do with a topic, that they want you to be interested in some topic, then probably they're looking for a scientist who can do exploratory analysis, and that you should really highlight that in your cover letter, that this is something I'm interested in. So for example, I work for a science funding agency. So to work for us, you should be interested in science policy, and you should express that interest. And I don't really care if you know so much about servers, but if you do know a whole bunch about servers, great, that'll make it more efficient. But that's not a requirement, even though in the job ad, it'll say that you should know SQL and that kind of stuff. Whereas if the ad is more technical without a topic that is highlighted, I would guess that that then is more of a slightly more towards IT.
Yeah, I would echo, definitely look at the job ads. And I mean, if you spend time now, just going on Glassdoor or Indeed or whatever and looking at data science ads, you'll start to sort of see the different kinds of profiles that ads tend to look for, because there are a lot of ads that are sort of, I mean, there's sort of, I think, two common flavors of data scientists. One is more these like machine learning engineers, where like the goal for that person is to build some model that goes into production in an app or whatever, where it's like, it's not about communicating information to person, it's just building it, and they want it to be productionalized and they want it to be production quality. And usually for those jobs, you really need strong computer science skills. And then there's also this sort of, I think where most of us fit is this more decision scientist role, where it's like the goal is to look at the data to try to give people information to help make decisions, so basically take the data they have and turn that data into the answer to a business question, or a question about science or whatever it is, and so often for those kinds of things, you need less deep computer science. I mean, you still need to be able to do what it takes to manipulate the data, and answer those questions, because often it's the kind of data that you have to work with in something like R or Python. But as long as you can do that, you don't need it to be like efficient code, you don't need it to be the kind of thing where it's going to replicate, like it's replicable code, that kind of stuff you don't need to worry as much about. And so those kind of decision scientist profiles are what you really want to target, where it's really like they want somebody who can like understand how to understand a problem and experiment. So you'll sort of see when you look at the job ads that there's these certain types that are more that, and that's it's pretty clear, for the good job ads.
And you can always ask the people in your network, right, about what kind of jobs, like what kind of jobs are they looking for? Okay, and then you can, like, if you have the inside information about what a job position really is, and then you compare it with what shows up, right? That starts to give you an understanding of how these things map, right? So like if you're just looking at the job from the outside, once it's posted, and trying to figure out why that job was posted this way, right? I mean, that's like inverse problem, but it's easier if you start with a few people that you know, look at the job postings that they post and ask them, you know, it's not even about saying like, I'm interested in applying. It's like, why did you structure it this way? What is it that's key about this job that you want? And then you'll start getting a feel for when you see a job, what's behind it.
So, okay, so we're about to hit the 2:15 mark in just a few minutes. So I do think we might have enough time for one question, but before that, just to make sure that I get this out of the way, I wanted to point all the attendees to a panel evaluation form that I'm going to post into the chat. So there's a link there, and you, if you complete that, you will be entered into a drawing for either fees for the fall semester or a $200 fellowship that will be applied to your account. So this is an encouragement for you to fill out the evaluation for the panel. I want to remind you that the next session will be at 2:30, and that's going to be another set of panels on education, communications, policy, social science, STEM, and startups. But so we do have time for maybe one more question before the end of the official end of the session. Does anybody have any questions left for the panelists? Okay, I see that Azin has a question.
Okay, first, thank you for the great panel and sharing your career journeys with us. My question is for someone who doesn't have a background in data science, and I'm basically thinking, other than the courses that you mentioned are helpful in getting a job in data science, what other experiences can be showcased to the employers that we want to like work in this field or area? Like, do we have to take projects or like try to work on a project in our research, or I don't know, some I know that there are some websites and stuff that offer these sort of projects, and is it helpful to like have those in our resume or background when we want to apply for jobs in data science?
My background is not data science. My PhD was in computer vision, but because I knew about coding and I knew how to be interested in projects, and when they said, do you have experience with big data? I said, I have experience with data and writing code that uses data. That was enough for them, because almost nobody has a degree in data science. So if you are comfortable writing scripting code and you've done projects that produce things, I think it's then a matter of selling yourself to show that you're interested in this is the kind of thing that you want to do.
I think it's also really important to understand that the CV or resume that you have for an academic position is completely different than one you have for an industry position. So if you're thinking about like, what do I put on my resume? Like, what section do I add these things into? Like, you know, I have my teaching, I have my, no. An industry CV is reorganized. You have to write it from scratch, and you have to look at how there's resources out there for how to structure the CV and what should go in there. And so I would definitely encourage you to look into that, because it's not a tweak. It's not like we add a section on our academic CV and then we are ready to go to data science. And I see Anand basically vigorously agreeing.
Yeah, I think a CV really goes a long way. It's not just to get an interview. It's also each interviewer will see your CV, and that's their first impression. So one tip to add to what Ioannis said is, you don't have to report everything you did in your in your PhD. You can select things that are actually relevant to data science. Say you built a code package and did it, put that in. Say you did, a regression model for something, put that in, reword it to sound more machine learning, but that's worked well for me. So try to see the data science in everything that you do and put that in your resume. And
Right,
I can't emphasize enough, you need to rewrite your resume. Make it should look like a data science resume, not an academic resume.
Have you done a project where you collected data? Talk about that. If you know how to do a survey, and avoid the pitfalls of selection bias and things like that, if you know how to code survey results, talk about that. That's useful data science skills.
Thank you.
Okay, so we have hit the 2:15 mark, and I want to be respectful to the panelists' time and the attendees. So I'm going to sort of officially call the session over, but anyone that wants to stay both from the side of the panelists and the side of the attendees, I think we can keep the room open for a little bit longer. But let's thank the panelists again, at least now officially, and maybe we can continue unofficially for a little bit longer.